Alright, this particular problem, you would think maybe that it's talking about velocity, particles velocity decreasing, but it's not. It's not. It's not talking about velocity. If we were talking about the velocity decreasing, that means the slope of velocity is negative, right? So, like, if we were to graph the velocity function, v of t, and we had something like that, the velocity would be decreasing from here to here, right? Those x values, because that's a negative slope. Decreasing means negative slope. So if we're talking about the velocity decreasing, we're really talking about the slope of the velocity, and the slope of a function we know that relates to derivative. So really, this is not talking about velocity, it's talking about the derivative to velocity, for velocity, which is acceleration. So this question is really saying at what times is the particle's acceleration negative. So it's a different type of question. So that's the same thing though. Particle velocity decreasing means acceleration is negative. Likewise, if the velocity is increasing, that means acceleration is positive. So let's see. We need the acceleration function then, and we'll do a sign chart for acceleration instead of for velocity. So what we have here is negative sine of t, and then we'll do a sign chart for acceleration. Because we're not looking for when velocity is positive or negative, we're looking for when it's decreasing, which is different than positive or negative. Alright, hopefully all of that explanation makes sense, and I'll just go ahead and finish the rest. If you don't need the rest, great, you can do it on your own, otherwise keep watching. So, a sign chart for acceleration, because I want to know when acceleration is negative. So, I set the acceleration function equal to 0, and we go to the unit circle. When is sine of t 0? Because that's the same thing. Sine of t is 0, or sorry, negative sine of t is 0 at the same places where just regular sine is 0. So sine is 0 at 0, t equals 0. At pi, t equals pi, and also 2 pi. And that's all we need to worry about. We don't have to keep going around the unit circle because it tells us we don't have to. And so I'll make my sign chart. And so those are my critical values. I don't need anything on the left side of 0 because it says it's bigger than 0 right there. So there goes that. I can have my test points. Actually, I don't even need anything on the right side of 2 pi for the same reason, because it only goes up to 2 pi. And then this is sine of a of t. So we're plugging it into that. So between 0 and pi, there's pi over 2. That's in between. So that's a test point that I'm going to pick. And then between pi and 2 pi, well, that's 3 pi over 2. And really, we don't even need even that much information, just because we know about the quadrants and what sign the signs are. That's weird. Okay, pi over 2. If we plug in pi over 2, we get a positive 1 out of sine. If we plug pi over 2 in, this gives us positive 1. Times it by negative, that's a negative. If we plug in 3 pi over 2, that gives us negative 1 from sine. Times it by a negative, and that's a positive. So, remember, when velocity is decreasing, that means when is acceleration negative? The acceleration is negative when from between 0 and pi. So that's when, so like if you wrote it as a sentence, the velocity is negative when t is in the interval 0 to pi. Not including 0, not including pi. There we go! That's it. Good day, sir.